The Leaning Tower of Pisa, a marvel of medieval engineering and a symbol of Italy's rich history, a wonder of the world, attracting millions of visitors each year who come to marvel at its unique tilt and historical significance. But why is it leaning? What caused this architectural anomaly that has fascinated people for centuries? The tower is a freestanding bell tower known as a campanile, and is part of the cathedral complex in Pisa, Italy. It's part of a cathedral in Pisa, Italy, standing proudly in the Piazza dei Miracoli, or the Square of Miracles. Construction began in 1173, during a time when Pisa was a powerful maritime republic. It took almost 200 years to build, with numerous interruptions and delays. The tower is 56 meters tall, an impressive height for its time. It started tilting just 5 years after building began. The tilt was noticeable even before the third floor was completed. The Leaning Tower of Pisa is famous for its tilt, a feature that has made it an iconic landmark. But this tilt was a mistake. It wasn't planned. The architects and builders were baffled by the unexpected lean. The tower leans because of its foundations. They're too shallow, only about 3 meters deep, and the ground beneath is unstable, consisting of soft soil that couldn't support the tower's weight. It's made of clay, sand, and shells, a recipe for leaning. This combination of materials caused the ground to shift and the tower to tilt. The tower's tilt worsened over time, becoming more pronounced with each passing decade. By the 20th century, it was leaning over 5.5 degrees. This was dangerous, and posed a significant risk to the structure's stability. The tower was at risk of collapsing, with visible cracks and structural issues becoming more apparent. Something had to be done to save this iconic structure. Engineers and experts gathered to devise a plan. The unstable soil beneath the tower was a major problem. It couldn't support the weight of the structure. It was like building on jelly. The ground was too soft and unstable. The soil layers shifted over time, causing the foundation to move and the tower to lean even more. This continuous shifting of the soil layers caused the tower to lean further and further. The uneven water table also played a significant role in the tower's tilt. During winter, the water table was higher on one side, exacerbating the lean. This made the ground even more unstable, especially after heavy rains. The tower was like a sinking ship on one side, continuously tilting and sinking into the unstable ground. Early attempts to fix the tower weren't successful. In the 19th century, engineers tried adding a concrete foundation, but this made the lean worse. They also tried using steel cables. They thought they could pull the tower upright, but these measures didn't work. They didn't address the real problem, the unstable soil. The soil composition, mostly clay, sand, and shells, continued to shift. The tower continued to lean. It seemed like an impossible problem to solve. In the late 20th century, engineers came up with a new plan to save the Leaning Tower of Pisa from collapsing. They decided to remove small amounts of soil from under the tower, a delicate and precise operation. They carefully drilled inclined holes beneath the north side, which was the most affected by the tilt. This is the side that was leaning the most, causing significant concern among the engineers. They slowly removed soil from these holes, a process that required extreme caution and precision. This reduced the tilt. It also stabilized the foundations, ensuring that the tower would not lean further. The tower was no longer sinking on one side, a significant achievement in the preservation efforts. To manage the uneven water table, they dug drains around the tower. These drains helped to level out the foundations by redirecting water away from the base. They also prevented further tilting by maintaining a consistent water level around the tower. The engineers also installed underground tubes, a modern solution to an ancient problem. These tubes were on the side opposite the lean, balancing the pressure on the foundations. They used these tubes to remove more soil, further stabilizing the structure and ensuring its longevity for future generations.